On a clear night during the right celestial season, any person with a simple backyard telescope can look toward Jupiter and see the planet's four largest moons. Ganymede is the largest moon in the solar system, exceeding planet Mercury in size. Io is the most volcanically active body in the solar system, while Callisto has one of the solar system's oldest and most cratered surfaces. But one of those four moons, Europa, has for decades stood out as a lightning rod for scientific curiosity. Beneath a layer of ice, scientists think there lurks a hidden ocean of water. And it may be the best place to look for extraterrestrial life in the solar system. To determine if a world about 484 million miles away has conditions favorable for life, scientists are sending a new spacecraft called Europa Clipper to conduct the first detailed study of an ocean world beyond Earth. Europa Clipper is a planned Jupiter orbiter with a focus to conduct detailed reconnaissance of Jupiter's moon Europa and investigate whether the icy moon could harbor conditions suitable for life or not. NASA's Europa Clipper mission will study the Jupiter ocean moon in detail and is scheduled to launch in 2024. And it will take about 3 years to reach Jupiter, just as a much smaller spacecraft would take on a direct route from Earth. The mission will place a spacecraft in orbit around Jupiter in order to perform a detailed investigation of Europa, which is a world showing strong evidence for an ocean of liquid water beneath its icy crust and which could host conditions favorable for life. The mission will send a highly capable, radiation-tolerant spacecraft into a long, looping orbit around Jupiter to perform repeated close flybys of the icy moon. The main objective of this spacecraft is to conduct a detailed survey of Jupiter's moon Europa and to determine whether there is presence of habitable conditions that can sustain life or not. The spacecraft, in orbit around Jupiter, will make about 45 close passes over Europa, shifting its flight path for each flyby to soar over a different location so that it eventually scans nearly the entire moon. The spacecraft also will swing by two other large Jovian moons, Ganymede and Callisto, to help shape and redirect its orbit. In 2016, NASA requested a budget of $30 million to formulate a mission to Europa. The mission would send a solar-powered spacecraft around the gas giant Jupiter to perform repeated close flybys of Europa over a 3-year period. In total, the mission would perform 45 flybys at altitudes ranging from 25 kilometers to 2,700 kilometers. However, Europa Clipper is still in its planning phase and early development, but the approximate cost estimate rose from $2 billion in 2013 to $4.25 billion in 2020. There has been a lot of debate in sending the spacecraft by using the Space Launch System, SLS. But NASA has requested the ability to use other vehicles, citing cost savings and the lack of available SLS vehicles, which for the next several years are devoted to the Artemis lunar exploration program. However, the model designed for the spacecraft shows that it will be about 20 feet in height, and its solar arrays will stretch 72 feet from tip to tip. At liftoff, it will have a mass of about 13,228 pounds including fuel for the journey. The scientists have to answer some big questions while they will launch this spacecraft. That's why Europa Clipper will carry a suite of instruments more advanced and sensitive than anything that's ever explored this Jovian moon before. Researchers don't yet know if Europa hosts environments suitable for life to exist, so the spacecraft won't carry life-seeking instrumentation. Because the Europa have to answer many questions like, does Europa really contain an ocean beneath its shell of ice? Does the chemistry of the ocean seem friendly for microbes? To answer those questions and more, Europa Clipper will be equipped with cameras to map the moon's surface at higher resolution, measure the heights of surface features, produce stereoscopic images, and seek evidence of geologic activity. The spacecraft spectrometers will study the composition of Europa's surface and the particles floating in space above it. An ice-penetrating radar will hunt for water within and below Europa's icy shell. A magnetometer will measure the strength and direction of Europa's magnetic field to determine how deep and how salty the ocean is. The spacecraft's dust analyzer will analyze tiny fragments of Europa blasted off the surface by micrometeorites. An infrared instrument will measure the moon's surface temperatures, seeking relatively warm regions where material may have erupted to the surface. Some of the instruments will also seek any material that may be spraying from the ocean into space as plumes. Analyzing that material would enable the spacecraft to analyze Europa's ocean composition without even landing on its surface. Because Europa is bathed in radiation trapped in Jupiter's magnetic field, Europa Clipper's payload and other electronics will be enclosed in a thick-walled vault. This strategy of armoring up to go to Jupiter with a radiation vault was developed and successfully used for the first time by NASA's Juno spacecraft. The vault walls, made up of titanium and aluminum, will act as a radiation shield against most of the high-energy atomic particles, dramatically slowing down the aging effect that radiation has on the spacecraft's electronics. But why the scientists have been studying Europa and not other Jovian moons? The search for life beyond Earth is one of NASA's primary objectives. If humans are to truly understand our place in the universe, we must learn whether our planet is the only place where life exists. So the search is on. But the universe is quite large. So, if we are to find extraterrestrial life, we must narrow our search. Extraterrestrial life might exist under all sorts of conditions that humans would struggle to imagine. Life needs a source of energy, the presence of certain chemical compounds, and temperatures that allow liquid water to exist. Jupiter's icy moon Europa seems to be just such a place. Scientists describe Europa as an ocean world because decades of evidence from analysis of spacecraft observations strongly suggest that an ocean of liquid water is hidden beneath the moon's surface of ice. In fact, some of Europa's characteristics would be extremely difficult to explain if the moon does not contain a global subsurface ocean. Europa is not the only ocean world. Two of Saturn's moons seem to be in the same category. Tiny Enceladus has a global saltwater ocean that sprays out into space as a plume of icy particles that fly hundreds of miles above its surface, and the large moon Titan is thought to have a subsurface ocean as well. But we begin our search with a world where research has been pursued for many decades, and where the questions to ask are very well defined. So off we go to Europa. But whatever Europa Clipper reveals, it could change our understanding of the solar system forever. Because this is a giant step in our search for oases that could support life in our own celestial backyard. The scientists are confident that this versatile set of science instruments would produce exciting discoveries on a much-anticipated mission. So, we all are looking forward for the successful approach of this spacecraft in our future.